Okay, today we're going to go through distance formula and midpoint formula. Um, Coming off of the properties of quadrilaterals and coordinate geometry, these are going to be two things that will be useful. We may ask you to prove that something is a uh, rectangle, and we may have it rotated, so we need to show that the side lengths are the same. So that's kind of where distance formula comes in. All right. So quickly, just kind of idea of what distance formula is and what it's used for. If we're looking at this diagram here of the quadrilateral HAYS, um, we can count the length of side HS right here because it's going straight up and down. So it's 1, 2, 3, 4, 5 units long. All right. We can count horizontal distances. The issue is when we try and count diagonally, like the length of side SY, we don't have a good way of counting that. We can't count it like we normally do up and down or left and right. So what we have is the distance formula, which helps us count um, lengths of line segments that aren't going straight up and down or straight left and right. All right. So the distance formula is right here. We have d for distance is equal to the square root of the whole quantity um, x2 minus x1 squared, and then add to that y2 minus y1 squared, and simplify. Now that at first looks kind of overwhelming, but really it's not that bad. So it's going to talk through kind of where this comes from, and then we'll put this into use and actually find the length of side SY. Um, so where the distance formula comes from is if we want to figure out the distance from S to Y, um, and we make this into a right triangle, all right, um, we have a right triangle. We can count distances left and right and up and down, I said. So I know that the distance from, let's call this for right now, point P for the time being. All right. Oh, that's bad. Let me just rewrite that. Point P. All right. I know that I can count the distance from S to P. It's 1, 2, 3, 4, 5, 6, 7 units long. And I can count the distance from P to Y because it's going straight up. It's 1, 2, 3, 4. Right? Now I have a right triangle. I know two of the side lengths, and I want to find the length SY, so I could use Pythagorean theorem. Okay, so it's basically an application of Pythagorean theorem, and then we've solved for the missing side, which we usually call C. We just replace it with the letter D. So this part right here, the subtraction of the x values. So my x values, the y value, the x value for point Y is 7, and the y value for point S, the x value for point S is 0. So 7 minus 0 is a total change of 7. So this part right here is just figuring out what's that horizontal distance, and then we square that because in Pythagorean theorem it's a squared plus b squared equals c squared. So that's where the squaring comes from. And then the plus is a squared plus b squared, right? Maybe I'll just write the Pythagorean theorem up top here. B squared equals c squared. Right? So this x2 minus x1 squared is really taking the place of a squared, and then we have the plus, and then b squared is going to be our change in y values. So we subtract the change in y values, in this case 4 and 0, to get that distance of 4 on the side. All right, so really what it is Pythagorean theorem. You can think about it with Pythagorean theorem if you'd like to. What we've done is we've just used Pythagorean theorem and solved for C, but then we just change C to be D because it's distance. Okay, so don't get too overwhelmed by the distance formula. So we'll just go through and do the application of this and figure out how long is side length SY. All right, using the distance formula. So I know that D equals, and it doesn't matter which one you choose as your x2 and x1 value. Just be consistent. So if you choose 7 as your x2 value, make sure you choose 4 as your y2 value because those are the coordinate points 7, 4. So that's what I'm going to do. I'll do the square root of 7 minus 0, quantity squared, plus And I'm going to use 4 as my y2 value, and that's squared. All right, now we're just going to simplify under the square root. Parentheses first, so 7 minus 0 squared is 7, and 4 minus 0 squared is 4. So we have this. Just continuing, we're going to square before we do the square roots. We have 49 plus 16. Add those together because we're under the square root. We get 65. So the length is equal to about 8. It's going to be a little bit more than 8 because the square root of 64 is 8. It'll be 8.0 something. All right, so just know that I just rounded that to 8.0. But it is going to be slightly over 8 as the length of SY. Obviously, we can't count that. That's where distance formula comes in. Again, that's just the application of Pythagorean theorem. So we're going to say this is 8.0. Good. All right, the next thing is midpoint. So midpoint is what's halfway to a certain value. All right, so since we know the length of SY, I'm going to find what is the midpoint of side length SY. So it's halfway from point S to point Y. It's somewhere in here. I want to know the coordinates of the exact midpoint, or halfway, from point S to point Y. All right, so the midpoint formula is right here. We have M for midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So just talking through what each of these represent, kind of like we did with the distance formula, we're really just taking the average of the x values to get what's halfway there. So if we think about, if we have test scores of an 80 and a 90, what is our average test score? We take those, we add those together. 80 plus 90% equals 170. And then we divide that by the number of tests we've taken, so 2. And then we get our average is 85%, right? So that's how we average. We're doing the same thing, but with the values of x and the values of y to find halfway, or what's the average, okay? So basically this is just saying average your x values, average your y values, essentially, and that's going to be the coordinates, because these are representing the ordered pair, and this is the common between, okay? So basically we're averaging the x values, averaging the y values, so that's going to give us the coordinates of the midpoint. Again, it doesn't matter which one you choose as your x1 value, which one you choose as your x2 value, just stay consistent with that with y, all right? So I'll choose 0 as my x value, and x1 value, and 7 as my x2 value. So I have the midpoint equals 0 plus 7 divided by 2, and then 0 plus 4 divided by 2. It's going to give me the coordinates of my midpoint. All right, so we have m equals 0 plus 7 is 7 divided by 2, and 4 divided by 2. And we're just going to split each of those in half to come up with the actual coordinates of that midpoint. So 7 divided by 2 is 3.5. 4 divided by 2 is 2. So this, or these, are the coordinates of the midpoint. So if we go back and find that point on our line SY, 3.5 comma 2 is 1, 2, 3.5 up to 2. So it's right here. That is point M, and it's halfway from point S to point Y. If we look at and draw a slope triangle in here, we're moving up 2, and we're moving over 3.5. You move up 2 and over 3.5 again, and you get directly to point Y. Okay, so we have 2 of those slope triangles. Each of them are 3.5 and 2. But the quick way to find the coordinates because we may give you points that are really far apart. You don't have to count those. Is to use the midpoint formula. So basically average your x values, average your y values. That's going to give you the coordinates of the midpoint.